All right, students, this lesson will be about 1.4, which is the rules of exponents. Now, there's a lot of rules of exponents. They're going to start with the zero exponent and tell you what it is. What I'm going to try to do here is sort of explain why it is. Okay, so the rule says that 4 to the 0 equals 1. And it says for any non-zero number, a to the 0 equals 1. And 0 to the 0 is undefined. So what exactly does that mean and why is that? Well, let's try and investigate that before we even get into negatives. All right, so I have a piece of scratch paper here, so I'm going to try and go through and see if we can build our laws here. Now, let's start with something we know. Let's say 5 squared. Well, 5 squared by definition is 5 times 5. All right, it's 2 5s. 5 to the third would be 5 times 5 times 5. 5 to the fourth, well, you get the point, 5 times 5 times 5 times 5. So if we did these, multiply these out, we get 25, we get 125, and here we get 625. Okay. But let's work backwards. What if you had 5 to the 1? You might be like, well, why would you write that? Well, it does come up. There are times when you need that. Well, 5 to the 1 means write 5 one time. Okay, and 5 to the 1 would just be 1 5, so it would just be 5. And 5 to the 0 then, well, what would we do? Now we got to think here. Should it be 0? A lot of students would say it should be 0. But think about this. As we go down this way, we're multiplying. 5 times 5 is 25, times 5 is 125, times 5 is 625. As we go up this way, though, we're dividing. See if you notice that. 625 divided by 5 would give you 125. Divided by 5 would give you 25. Divided by 5 would give you 5. So if we're going to continue this pattern, we need to then divide by 5. Each time here, we're dividing by 5. And if that doesn't make sense, I apologize. Take your calculator and do 625 divided by 5. You'll verify that it is 125. 125 divided by 5 will be 25. 25 divided by 5 will be 5. So then the only answer that makes sense here is 5 divided by 5. That would have to be 1. All right. That's how you can remember. That's justification for why is 5 to the 0 1. Now, this works for any 5, any number. This could be a 10. It could be 3.1. We can call it an x if we wanted to. So this rule works for any x. So we would say any x to the 0 is 1. All right. Now, for our negative exponent rule, let's see if we can continue this. I ran out of paper. Let me slide in another sheet. We said, wait a minute. Going up this way, we went from 5 to the 4, 5 to the 3, 5 to the 2, 5 to the 1, 5 to the 0. The next one should be 5 to the negative 1. Okay, well, what should that be? Well, according to this rule, we went divided by 5, divided by 5, divided by 5, divided by 5. So this should be 1. Divided by 5 should be 1/5. That's where we get this rule that 5 to the 1 is 1 over 5. Sorry, 5 to the negative 1 is 1 over 5. It becomes a fraction. If we continue this rule, 5 to the negative 2 should be 1 over, if we divide it by 5, that'd be 1 over 25. Okay? Because the other way to think about this is dividing by 5, dividing by 5, dividing by 5, we're multiplying by 1/5. That's the same thing. Okay? So this is going to become, if we think about this, that's really 5 squared. So that's where you get this idea that if you have a negative exponent, you just flip it around. Okay. But what I see is it sort of fits into this bigger picture here. Okay. So with that, we should be able to go backwards to any number we want. And so basically, you're dividing by 5, dividing by 5, dividing by 5. So that's just same as multiplying by 1/5. All right. Dividing by 5 is the same as multiplying by 1/5. Okay, so that's how you can go up or down, and that's how you get negatives and positives. and how you see where the whole numbers fit into this. Okay, where the whole number of exponents fit in, where the negative exponents fit in, and where the zero exponent fits in. All right, thanks for watching. All right, so we're still working with the properties of exponents. We're still in section 1.4. This is the core concept. It has second core concept we have. It has 3 different properties. In total, there's about 7 properties of exponents you want to know. That's kind of confusing. So what I try to do is I try and understand them rather than just memorize them. It makes it less memorization and more that if I get stuck, I can do it the long way and get back to my shortcuts. Because that's all these are. These are really sort of shortcuts. So let's not worry about the names too much, but I'll explain them. Product of powers. Product means multiplication. Quotient of powers means division. Power of a power means you're doing an exponent to an exponent power. So power of a power. That one actually will make more sense when you see it. But basically this one just think it's multiplication. This one's division. I know it looks like fractions, and fractions are division. And we're going to be okay with that. Okay? And we'll also talk a little bit about why do you want to do this. But first, what is it? Okay. So here's what we have. We have 4 to the 6, 4 to the 3. Let me rewrite it. If you're copying your notebook, I highly suggest that. 4 to 6, 4 to 3, because here's what we're going to do. 4 to the 6, what does it really mean? It means 4 times 4 times 4 times 4 times 4 times 4. So 4 times itself 6 times. There's 6 4s here. 4 to the 3rd would be 4 times 4 times 4. You see where we're going with this? All in all, since you're multiplying these, you have a total of 9 4s. No one's going to write it out this way. We write 4 to the 9. All right, and that's what we do. Okay. Now you might be like, well, why would you even do that? Well, part of why we do this is, if you do this on a calculator, 4 to the 9, when you get that answer, it's going to change it into this big old thing like that. I think it's easier, and I think you'll agree, it's easier to write 4 to the 9 than writing this answer. So if you try to do this original problem in here, it won't spit out 4 to the 9. It'll jump straight to this answer. All right. You could do it. 4 to the 6 times 4 to the 3rd. You got to make sure you have a calculator that does these exponents. That's the little exponent button on our calculator. Looks like a little up arrow here. You can do that on a keyboard too if you're ever using an online calculator. But again, it'll give you this. It won't give you the 4 to the 9, and so that's one reason why you want to do it. The other reason, if you're going into engineering, or really I wasn't going into engineering, but I really dug astronomy. So if you're talking about big distances, like distances to a galaxy, like 10 to the 12th, and then you're going to multiply that by some other distance, and it's like 4.1 times 10 to the 3rd, you want to be able to approximate this without chunking it all into the calculator. The 10 to the 12th and 10 to the 3rd would end up with a 10 to the 15, according to our rules. And that gives me an approximate number. Then we would have to worry about this. But for the most part, it gives you a rough estimate. Okay. The other reason that is important if you're not doing numbers for astronomy and stuff like that, when we're talking about large amounts of money, like what the U.S. Congress is working with, we're talking billions of dollars. That's like 10 to the 9. That's important to keep into perspective because that's 9 zeros. So all these things, it's easier to represent with numbers like this. When we write all this, it has more whoa factor, we'll call it. All right, let's get back to the rules, though. All right. So what we got? Quotient property. Okay, quotient property, like I said, just means division. So let's see why they did what they did. It says to divide powers, subtract their exponents. Why is that? Well, let's write this out. 4 to the 6 and 4 to the 3rd. And again, I suggest writing this in your notebook. 4 to the 6 would be 4 times 4 times 4 times 4 times 4 times 4 times 4. And 4 to the 3rd, as we said, is 4 times 4 times 4. Okay. But what does that mean? Is that any easier? No. We wouldn't usually do this, but this will help you understand why they do subtraction. Here's what we got. Every time you have 4 over 4, we know that. Think about this. We'll pop bubble here. There you are, thinking. You know 4 divided by 4. That's 1. That's a nice one. That's easy. So every time you have a 4 divided by 4 here, that's just a 1. That's a 1. That's a 1. Wait, but we're left over. We're left over with 3 4s left over, so 4 to the 3rd power. All right? The shortcut is they looked at this and said, hey, just do subtraction. And say it's 4 to the 3rd. But the logical reason why we're subtracting is it's canceling is really what it is. Okay, all the 4 divided by 4 is just 1, so it cancels itself out, and that's your shortcut for that. All right, we got one last shortcut to talk about this core concept. Let's take a look at it. Power of a power. Last one here, power of a power. It says to find the power of a power, multiply. And that's what students get confused by. Like, wait, sometimes I multiply, sometimes I add, sometimes I subtract. Well, let's write it out the long way. Let's use their example, 4 to the 6, raised to the 3rd. Okay. This is going to take some writing, so I wouldn't usually suggest this. But here's what it is. 4 to the 6 raised to the 3rd. Well, 4 to the 6 means there's 2 different ways to do this, and I'll do it both ways. That's 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. But we said do that to the 3rd power, so it's going to be write this thing, repeat it, 3 times, because it's the 3rd power. We're going to do 3 times, 4 times 4 times 4 times 4. I'm not going to write them all out. That's kind of crazy, because you can see how many we're going to have, right? If we have 6 4s here, we have 6 of them, 6 of them, 6 of them. We have a total of 18 of them. Okay? So the rule is multiplication. The y of it is, if you wrote it out this way, and then expanded that, you're doing both expansions. 4 to the 6 means 6 of them. To the 3rd means do that 3 more times. It's like a million. You know, do this a million times and then a million times. That's 4 to the 6 to the 3rd. That's how it becomes a real big thing. But the shortcut is you do multiply the exponents. Alrighty. Those are your core concepts for that part. There's one more core concept box left, and that's coming up. That's true. So we're still working with the exponent properties. There's the last 2 ones. We're still in section 1.4, and the core concept here has power of a product and power of a quotient. Again, don't worry too much about the names. Product is multiplication, quotient is fraction or division. Okay, that's all it means. It's just fancy words and stuff like that. Let's go and run through the numbers. That's really what you want to focus on. 3 to the 2 raised to the 5. Sorry, 3 times 2 raised to the 5. And they're saying the shortcut is you go 3 to the 5 times 2 to the 5. So basically, it's like a distribution. It's like the exponent gets applied to both of them. Okay. And if that makes sense to you, you can follow that rule. But if that doesn't make sense to you, let's figure out why it does what it does. Well, 3 times 2 to the 5th power really means, again, this is not 3.2, it's 3 times 2. So it's 3 times 2, 3 times 2, 3 times 2, 3 times 2, 3 times 2. See what I'm doing here? I said 5th power, so I had to write it 5 times. Well, let's reorganize this craziness. There would technically be 5 3s and 5 2s. In other words, it would be 3 to the 5 times 2 to the 5. That's the shortcut. Okay, so that's what this thing is. The rules in the book are a shortcut. What the logic is that they don't show you behind the moves, behind the scenes there. The logic behind it is right there. It's because you're doing, exponents are just repeated multiplications. That's all it is. It's all an exponent is. It's a rule for repeated multiplication. Let's turn this over. Let's take a look at the bottom part. Power of a quotient. Let A and B be real numbers with B not equal to 0 and M be an integer, and don't worry about all that. Let's focus on the numbers. 3 over 2 to the 5th power. What it essentially does is the same thing here. It applies to the numerator and the denominator. It applies to both. So it's saying 3 to the 5th, sorry, 3 over 2 to the 5th, sorry, let me pronounce that right. 3 over 2 to the 5th. They're saying that would be 3 to the 5th, 2 to the 5th. And again, if that makes sense for you as a rule, then that's great. But for a lot of us, I don't understand what you just did there. Okay, well, let's figure that out. 3 over 2 to the 5th power means, write it 5 times. Oops. It's the same thing 5 times. I shouldn't switch up. So 3 over 3, 3 times 3 times 3 times 3 times 3 times 3 times 2 times 2 times 2 times 2 times 2. So essentially, how many 3's? You have 3 times itself 5 times, and 2 times itself 5 times. And it's 3 to the 5th and 2 to the 5th. So this is basically, like I said, think of this as a shortcut. And then this is the, you can call it the long cut or the mechanics of why does that work? Why does it do that? Okay. So for a lot of problems, you're going to try and write them out like this. But once you get into the textbook examples, they will start to throw some X's in there. And it can be kind of tricky, so make sure to ask your teachers in class. I know a lot of times these examples in the book are, okay, I get that. But you get to the homework questions and it's like, whoa, that's a lot more variables than I expected. So make sure to ask in class, and thanks for watching.